Hello viewers, how are you? Hope so you are fine. I am Ali Moazzam and you are watching about Ali Maths Online. Today we will discuss about fractional calculus, which is a vast and hot topic among the researchers and very interesting topic. Okay, we will discuss about conversion of classical calculus to the fractional calculus, generalized form of the factorial functions, basic idea of fractional order derivatives and their examples. Okay, firstly, as we know about the classical calculus and ordinary derivative, let we have a function y is equal to f of x and its ordinary derivatives are like first derivative of y will be written as dy over dx. Second order derivative describes as d2y over d of x square up to so on, and the nth order derivative is described as dny over d of x raised to power n. As these are mentioned ordinary derivatives of the function y. Now we will discuss about the fractional order derivative. What is the fractional order derivative? As we can see that the first derivative indicate first order derivative, which is 1, and the second order derivative is 2. We will describe what will be happen if a derivative d of 1 over 2 of y over d of x 1 over 2 exists in it. It means we will discuss about arbitrary order derivative of a function in fractional calculus. To elaborate the idea, we will discuss by an example. Let we have a function y which is equal to x square as mentioned in the figure. As we can say that y is equal to x of square and its graph is a parabola which is mentioned by black marker. Okay. Let me have first derivative of x square which is 2 of x. This is a straight line. That is a straight line. If we take the second derivative of the given function, the value will be d2 of y over d of x square, which is equal to 2. It is a constant, and the graph of the functions is described as the first derivative of x square is described by a straight line mentioned by red marker as in figure, and the second derivative of the function is described by a straight line. This is an intercept form which is parallel to x-axis mentioned by blue marker, which is 2. The question arises here is that how a curve which is a parabola turned into a straight line directly. The Leibniz was the first mathematician who gives the idea about it and think about it, how this parabola is transferred to a straight line. It means there must be some derivative exist in it which continuously convert this parabola into a straight line and this straight line to a intercepted form which is described by blue line. So it means in fractional calculus we will discuss about the arbitrary order derivative. Okay, so fractional calculus defined as fractional calculus Okay, now we will study about fractional calculus. What is fractional calculus? Fractional calculus is a branch of applied analysis of functions or models of any situation at arbitrary ordered derivative. And this idea is not new. As I said that Leibniz was the first mathematician who described, in fact, who gives the idea that how this curve transferred into a line. It means, as in classical calculus, derivative mentioned as first derivative and second derivative, it means there must be exist some kind of derivative like 0.1 order derivative, same as it 0.2 derivative, and so on till to the first derivative. It means these derivative will describe that how this curve transfer to the straight line. To explore this idea, I will mention the factorial function. Let me have discussed about what is the factorial function. Okay. Factorial functions. We will continue our study about fractional calculus by understanding the factorial functions. As all we know about the factorial functions, that factorial function of an integer n is described as n into n minus 1 factorial. For example, factorial of 1 is 1. Factorial of 2 is 2 and 1. The factorial is 3 is 3, 2, 1. Again, the question arises, what will be the factorial of 1 over 2, 1 over 4 or any other number? So, this is the flaws between the study, that factorial function only exists if n belongs to a positive integer. If n belongs to a positive integer, what will be the behavior? If the number is a real number or a complex number. So, to generalize this factorial function, Euler is the first mathematician who generalized this factorial function in the form of gamma and beta functions. Let me have defines the gamma function. What is the gamma function? So, the gamma function okay. Let me discuss about gamma function. Gamma is the generalized form of the factorial functions defined as gamma of alpha is equal to integral of 0 to infinity. 0 to infinity e raised to power minus t, t raised to power alpha minus 1 d of t, where alpha belongs to a real number. Okay, that's a gamma function which also describes these factorial. If we replace alpha by 2, the result will be of this integral equal to 2, and if we replace this alpha by 3, the result of this integral will be converted to 6. It means the gamma function is a function which can describe the general form of the factorial function. Also true for when the alpha is an integer, also as well alpha is a real number. So this is basically that's the concept which help us to study the fractional calculus and the behavior which turned us from the classical calculus to the fractional calculus. Okay, let me have an example of power rule of classical calculus. Okay, next we will see that how we can turn the power rule of the ordinary calculus to the fractional calculus. Let me have a function. Let y be a function which is x raised to power n. As we mentioned its first derivative, that will be d of y over d of x, which is equal to n x into n raised minus 1. If we discuss about second derivative, the second derivative of x raised to power n will be equal to n into n minus 1 into x raised to power n minus 2. So I can write it as n into n minus 1 into n minus 2 factorial over n minus 2 factorial, as multiplying and divide by n minus 2 factorial, the result will be like as. Okay, so that value will be equal to n factorial over n minus 2 factorial into x raised to power n minus 2. If we describe the third derivative of this function, the value will be d3 of y over dx cube is equal to n into n minus 1 n minus 2 into x n raised to power n minus 3. Okay, next d3 of y over d of x cube is equal to, if I multiply n minus 3 factorial and divides by the same value, we will get n into n minus 1 into n minus 2 into n minus 3 factorial over n minus 3 factorial into x raised to power n minus 3. So we can write it as n factorial over n minus 3 factorial x raised to power n minus 3. As we can see from these behavior that derivative of first derivative of x raised to power n, second derivative of x raised to power n, and the third derivative of x raised to power n gives us a pattern that if k is less than for some integer n, then the kth derivative of y will be equal to n factorial over n minus k factorial x raised to power n minus k, where k belongs to an integer, the positive integer. Okay. As we can see that these values are true for some integers k. As we are studying about fractional calculus, we want to move the derivative, not the ordinary number 1, 2, 3, but also the arbitrary number which may be 1 over 2, which may be pith order, which may be a plus b iota orders. It means we want to move our system from classical to fractional system. Okay, let we write its generalized form as if we replace k by some alpha where alpha belongs to real numbers. Then what will be the results? The result will be d of alpha of y over d of x of alpha is equal to n factorial over n minus alpha factorial x raised to power n minus alpha, where alpha maybe belongs to a real number. Okay, there's a problem, that is factorial function is only defined for the integers. Here's the clause that n minus alpha, as the factorial function is only true for the integers, but here's alpha is a real number, so the results will also be a real number. That's why the Leibniz was stopped here, because there is no any other solution to describe all of this. Then Euler was the first mathematician which gives the ideas of the gamma function as I described before. Let me use here gamma function. The gamma function is written as gamma of alpha is equal to integral from 0 to infinity e raised to power minus t raised to power alpha minus 1 d of t, where alpha is a real number. Okay, let me have some properties that we will use solving and generalize this result. The first property of the gamma function is gamma of alpha plus 1 will be equal to alpha factorial. And the second property is gamma of alpha plus 1 can be described as alpha into gamma of alpha. For specific number 1 over 2, gamma will be square root of pi. The result will be square root of pi. Let me use these results to generalize this formula for the x raised to power n. Let the first result will be used here, that alpha factorial is a gamma function if I increase alpha by 1. So if we convert this factorial function into gamma function, we increase this function by 1. So result will be d of alpha of y over d of x of alpha will be equal to n factorial over gamma of n minus alpha plus 1 x raised to power n minus alpha. Okay. The fractional derivative is not described in this form, so we can write it as d of alpha of y can be described as n factorial over gamma of n minus alpha plus 1 x raised to power n minus alpha, which is the power role of fractional derivative described as. Okay. Let me have an example to describe this formula. Is it true or not? Okay. Let me have an example. Let to find derivative of x of order 1 over 2. So we can see in the formula that 1 over 2 is the alpha. It's the order of the derivative and the power of x is 1. So for the formula of this function, n will be equal to 1 and alpha will be equal to 1 over 2. If we replace the values in the formula, we will get 1 over 2 derivative of half order of x is equal to 1 factorial over gamma of n value is 1 minus 1 over 2 plus 1 into x raised to power 1 minus 1 over 2. Okay, next we have 1 factorial is also equal to 1 over gamma of 3 by 2 into x raised to power 1 over 2. As we have this function, we can write it as 1 over gamma of 1 over 2 plus 1 into x raised to power 1 over 2. By using the second property of the gamma function, we can write it as square root of x over 1 over 2 into gamma of 1 over 2. Sorry, there's not a square root, there's a value of gamma. Okay, the result will be 2 into square root of x over square root of pi, which is the value of half order derivative of x. As we can see that this formula is only true for the function when the function is a polynomial. To find the derivative of trigonometric function or any other kind of function, we have to solve some other formula and describe their derivative. Okay, let me have a constant function to describe as. Okay, let y be a constant function which is c. Okay, so we can write it as y is equal to c into x raised to power 0. Okay, by using the formula of the fractional order derivative for the polynomial, here's the n is 0 and alpha is 1 over 2 as we are taking the derivative of half order. Okay, now by putting the values in the formula, we will get 1 over 2 derivative of constant will be equal to 0 factorial over gamma of 0 minus 1 over 2 plus 1 and x raised to power 0 minus 1 over 2. Okay. 0 factorial is 1 and the value of after simplification will be equal to 1 over 2 and x raised to power minus 1 by 2. The result will be equal to 1 over gamma of 1 by 2 by the third property will be equal to square root of pi and x raised to power minus 1 by 2 will be equal to square root of x. That result is totally surprising as we can see that in the ordinary calculus the derivative of a constant is 0, but here's the derivative of the constant is not 0 but it's a form of x. It means there's a variable involved in it. Okay, that is also a flaw because If we check this result at x is equal to 0, this result will not be a continuous. So, as we can see that the derivative of a polynomial p of x and its derivative is continuous. This polynomial is continuous, then its derivative will also be a continuous function. So, here's a function which is between this simple function and the derivative exists in it. That's the half derivative, and this is not a continuous function. It means this is a contradiction. This is not true. It should be continuous. So there is a flaws in this formula. So we will look forward for a formula which is much appropriate than this derived formula. We will discuss that formula in the next video.